Assalamu alaikum. Welcome to another video. Today we will discuss chapter number 14, that is current electricity, and we will discuss its further topics. So the topic we are going to discuss is voltmeter. As we know that a voltmeter is used to measure the potential difference across 2 points in a circuit, and it is always connected in parallel with the components across which the voltage is to be measured. Key points regarding voltmeter and potential difference are: Number 1, potential difference derives current in a circuit. Number 2, it is measured in volts using a voltmeter. Number 3, a voltmeter has high resistance so that it may prevent current from flowing through it. Number 4, more the potential difference, more will be the energy per charge, thereby making the bulb glow brighter in case of a circuit. Now let us consider the real-life application of potential difference. For example, charging a mobile phone. When you plug your phone into a charger, the charger provides a potential difference that is usually 5 volt for USB charger across the battery terminals. So this potential difference basically pushes electrons through the circuit, thereby allowing current to flow and charge the battery. Like as we measure the potential difference by using voltmeter, similarly, EMF is also measured using a voltmeter, but it must be measured when no current is drawn from the source. So to do this, connect a high resistance voltmeter across the terminals of the battery when it is not connected to the circuit. The voltmeter reading gives the EMF of the battery. Next is Ohm's law. Ohm's law states that the current I passing through a conductor is directly proportional to the voltage across it, provided that temperature and other physical conditions remain constant. Mathematically, V is directly proportional to I, means voltage is directly proportional to current. By introducing a proportionality constant, that is R, we get V is equals to IR, where V is equal to voltage that will be measured in volts, I is equals to current that will be measured in amperes, and R is equals to resistance that will be measured in ohms. So resistance, what is resistance? It is the property of a material that opposes the flow of electric current through it. यानी जो भी किसी मटेरियल में से करंट पास करता है, रेजिस्टेंस उसके फ्लो में, उसके पाथ में रुकावट पैदा करता है. It basically determines that how much the material resists the movement of electrons in a circuit. Mathematically, resistance is given by Ohm's law. That is, R is equals to V divided by I, where R is resistance, V is the voltage, and I is current. The unit of resistance is the ohm, that is named after George Simon Ohm. This means that a conductor has a resistance of 1 ohm if 1 ampere of current flows through it when 1 volt is applied across its ends. So, what we get from Ohm's law is that if we increase the voltage across a conductor, the current also increases proportionally. And if the resistance increases, the current decreases for the same voltage. So, the resistance depends on the material, length, and the cross-sectional area of the conductor. Now, let us draw a graph for Ohm's law. So for a resistor with constant resistance, the voltage vs current graph is a straight line passing through the origin, and the slope of the line gives us the resistance. A steeper slope means higher resistance. Here we have shown current along x-axis and the voltage along y-axis. So if the resistance is constant, the graph remains a straight line, and if the conductor heats up, resistance may change and the graph may curve slightly. Consider an interesting example of water flow analogy. Think of a water pipe. The voltage is like water pressure that is pushing water through the pipe. The current is like the flow of water, and the resistance is like a narrow pipe that may be restricting water flow. So if we increase the water pressure, that is voltage, more water flows, that is current. Means if we increase the voltage, more current flows. But if the pipe is too narrow, that is high resistance, then less water flows even at high pressure. Okay, next is ohmic conductors that follow Ohm's law. So let's define it. Ohmic conductors are those materials that strictly obey Ohm's law, meaning their resistance remains constant regardless of the voltage or current applied, provided that the temperature and physical conditions remain unchanged. So mathematically we can define it as V is equals to IR, where V is voltage, I is current, and R is the resistance. Some of the examples of ohmic conductors include metals like copper, silver, and aluminium that are used in electrical wiring, resistors, as you know, fixed resistors in the circuits, and tungsten filament. Now, in the graph of ohmic conductors, the voltage vs current graph is a straight line passing through the origin. The slope of the line represents resistance, which remains constant. Next is non-ohmic conductors that do not follow Ohm's law. So let's define it. Non-ohmic conductors are the materials that do not obey Ohm's law, meaning their resistance changes as the voltage or current changes. As we know that for non-ohmic conductors, V is not directly proportional to I, so the equation V is equals to IR does not hold with a constant R. For example, filament bulb. As temperature increases, there is an increase in resistance also. Diodes and LEDs, these two allow current to flow in one direction only. Number 3, transistors and semiconductor, the devices where resistance changes depending on the applied voltage. So for the graph of non-ohmic conductors, the voltage vs current graph is not a straight line and the slope changes, indicating that there is a change in resistance as well. Now let's discuss the factors affecting the resistance. As we know, the resistance of a conductor opposes the flow of electric current and is influenced by the following factors. Number 1, length of the conductor. Number 2, cross-sectional area. Number 3, material of the conductor. And number 4 is temperature of the conductor. So let's discuss length of the conductor. As we know that resistance is directly proportional to the length of the conductor, that means that a longer wire offers more resistance because electrons have to travel a greater distance, encountering more collisions with atoms. Number 2 is cross-sectional area. So resistance is inversely proportional to the area of the conductor, means a thicker wire has a larger cross-sectional area, thereby allowing more electrons to pass through, which reduces the resistance. Number 3, material of the conductor. Different materials have different resistivities. Resistivity is a property of material. So, for good conductors, for example, copper, silver, resistivity is low, so they offer low resistance. And for insulators, for example, rubber, plastic, resistivity is high, that will be offering high resistance. For temperature of the conductor, for most metals, resistance increases with temperature. So, when temperature rises, atoms in the metal vibrate more, thereby increasing collisions with electrons, which further increases the resistance. However, for semiconductors, resistance decreases with temperature. So that's all. Thank you.